Okay, this video is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 4.4, and today we're going to talk about properties of log functions. All right, so by the end of this lesson, you will be able to convert from log of products, powers, and quotients to expressions in terms of individual logarithms and conversely. We'll also be able to simplify expressions of type log base a of a to the x and a to the log base a of x. All right, so the first thing we're going to talk about is the product rule. The product rule states that for any positive numbers m and n and any log of base a, log base a of m times n is equal to log base a of m plus log base a of n. So essentially all we're doing is we're taking the product and we're splitting it into two different logs using addition. Okay, so the log is a product, log of a product is the sum of the logs of the factors, is a fancy way to say it. Okay. All right, so what we're going to do is we're going to take log base 3 of 9 times 27, and we're going to expand that using the product rule. Okay, so using the product rule, what we're going to do is we're going to take these two factors, and we're going to separate them into two different logs and connect them using addition. So log base 3 of 9 plus log base 3 of 27. Okay. And that's our product rule. All right, so let's try another one. We're going to take it and we're going to work in the opposite direction now. Notice that we have two logarithms connected using addition, and we're going to take this and condense it so that we have one log. Okay, so we're going to be going from two logs to one. So we're going to write log base 2, and then our factors we simply write as a product of factors. Okay, so that's working in the opposite direction. So we go from multiplication to addition, and addition back to multiplication. Okay, so let's take a look at another rule. Our next rule is called the power rule. The power rule states that for any positive number m and any log base a and any real number p, if I have log base a of m raised to the p power, that's going to equal p times the log base a of m. Okay, so essentially what we're going to be doing is we're going to be taking that exponent of p and then putting it out front and multiplying it by the log of m. Okay, so it just pops right out front. So let's take a look at an example. We're going to express log base a of 11 to the negative 3 as a product. Okay, so again, what we're going to be doing is we're going to take this exponent here, and we're going to simply move this exponent out front. Negative 3 times log base a of 11. Okay. Our next example, we're going to express the as a product, log base a of the 4th root of 7. Okay, so the first thing that we notice is the radical is not written as an exponent, so we do have to remember our radical to exponent rules. Just a reminder, if I have the square root of x, this is the same as x to the 1/2 power, okay? This value here is your index, this value here is your power. So index becomes denominator, power becomes numerator. So my first step is to rewrite this using rational exponent. So log base a of 7, the index is 4, the power is 1, so this is going to be raised to the 1/4 power. Once I have that, the next step becomes quite simple. We just take that exponent and we bring it right out front. 1/4 times log base a of 7. Okay, so let's look at one that involves a natural log. Remember, our natural logs act in the same manner as our common logs or our logs of different bases. So there's not going to be anything that's different here for taking that exponent and moving it. Okay. So just like before, we're going to take this exponent, we're going to move it right out front. 6 times the natural log of x. Okay, so the next rule we're going to talk about is the quotient rule. For any positive numbers m and n, and any log base of a, if I have log base a of m divided by n, we can take that and expand it out using subtraction. Log base a of m minus log base a of n. So the log of a quotient is the log of the numerator minus the log of the denominator. Okay, so that's how we're going to expand it. Division will turn to subtraction. Okay, so let's look at our first example. We're going to express this as a difference of logs, log base t of 8 divided by w. Okay, so again, you're going to take these two values here, and we're going to expand this out, and division is going to turn into subtraction. So log base t of the numerator, 8, minus log base t of the denominator. So it's always numerator minus denominator. And that does matter. That order does make a difference, so please make sure that you're cognizant of that when you are expanding. Okay, so in this case, I've got log base b of 64 minus log base b of 16. Now, in this case, we want to condense it. We want to write it as a single logarithm. So we're working in the opposite direction. What you notice is we have that subtraction. That means that we're going to be taking this and we're going to be turning it into division. Okay, numerator minus denominator. So we should know that the first logarithm, this value of 64 will be in my numerator, and this value of 16 will be in my denominator. Okay, so log base b is 64 minus log base b is 16. We're writing it as a single logarithm. We're condensing it. Log base b of the first, that's our numerator, and the second, which is our denominator. Okay. If we wanted to go further, we could say that this is log base b of 4. Not necessary if we're being asked just to condense. Okay, so now we're going to go ahead and we're going to spend some time applying these properties and putting all of these things together to work with our rules in conjunction with others. So our first example, we're going to write this out in terms of sums and differences, as well as products. So I've got log base a of x squared, y to the 5th, divided by z to the 4th. Okay, so the first thing I notice is we have our division. It doesn't make a difference if we choose to do the multiplication or the division first. I tend to get rid of the fraction first because that tends to make most people nervous. So we're going to get rid of that division by turning it into subtraction in our first step. Remember, subtraction, if we're expanding, is going to turn into subtraction, or division, if we're expanding, is going to turn into subtraction. So we've got log base a of our numerator, x squared y to the 5th, minus log base a of z to the 4th. Okay. So the next thing I'm going to deal with is I'm going to deal with this product of factors here, x squared y to the 5th. I want to take that and I want to expand that out as well. And we know that with product, what we're going to do is we're going to expand it using addition. So since I have 3 variables here, I should wind up with 3 logs in the end. So log base a of my first term, or my first factor, which is x squared, plus log base a of y to the 5th, minus log base a of z to the 4th. And the last thing I'm going to do is I'm going to take care of these exponents. We know we have a power rule, and we know where those exponents go. So that's our very last step. We're going to take those exponents and we're going to bring them out front. 2 log base a of x plus 5 log base a of y minus 4 log base a of z. And this is completely expanded. Okay, so the next one that we're going to expand is log base a of the cube root of a cubed times b divided by c to the 5th. Now, the first thing that I need to deal with here is that radical. It's in the way. I can't get to what's in the radicand. I can't get to that without first removing that radical. And we know that when we're dealing with radicals, we don't like things to be written in terms of radicals. We like them to be written in terms of exponents or rational exponents. So that's going to be our first step, to turn this into a rational exponent. We know that the cube root is equal to a rational exponent of 1/3. Oops. So we're going to go ahead and rewrite that using my rational exponent. Okay. So there's our first step. Now, that 1/3 also needs to be moved so that we can get inside. So there's our second step. We're going to take this and we're going to move it out front. So we've got my 1/3 log of A of A cubed B divided by C to the 5th. Okay, so I want you to keep in mind, notice that this cube root is being taken of everything underneath this radical. So we have to make sure that this 1/3, now that it's out front, does get applied to everything here. And there's two different ways to do that, and we can look at both methods. But our next step is to take care of this division. We know that division, again, changes to subtraction. So that will be our first step. And I'll show you two different methods to continue to bring this 1/3 with us. Okay, 1/3 log A cubed B minus, and since I want that 1/3 to be applied to that C as well, 1/3 log of C to the 5th. An alternative way to do that is to keep that 1/3 out front and then put everything else in a set of parentheses so that afterwards that 1/3 need be can be distributed through. Okay. So now we can continue to expand this. Again, we see multiplication here, so we're going to expand that using addition. 1/3 log A cubed plus 1/3 log B minus 1/3 log C to the 5th. Or likewise, if we're doing our other option here, 1/3 log A cubed plus log B minus log C to the 5th. And then we move our exponents. Okay, the 3 comes out, the 5 comes out. So 3, when I move it out front, notice we've got that 1/3 here. So what we need to do, since this becomes multiplication, we need to multiply 3 and 1/3. 3 times 1/3, we know, is 1. So this simply becomes log of A plus 1/3 log of B minus, same thing here, 5 times 1/3, which is 5/3 log of C. I seem to have lost my A's along the way, haven't I? My bases. We do need them. Okay. All right, so this is done. We move over here. We have one last step here. Okay, move those exponents. 1/3 stays out front. This 3 comes forward. 3 log base A of A plus log base A of B minus 5 log base A of C. Both of these would be correct. So if you notice that 1/3, if I were to distribute this through, 1/3 times 3 would give us our 1 back, so log base A of A, plus 1/3 log base A of B, minus 5/3 log base A of C. So either way is correct. It just depends on which way you prefer to do this. Okay, so we're going to go ahead and expand, and hopefully this time we won't lose our base. So first thing we're going to deal with is that division. So as we know, when we're expanding, division is going to change to subtraction. So So our first step is to expand that piece out. I keep doing that. Log base b of ay to the 5th minus log base b of m cubed n to the 4th. Okay, so division turned into subtraction. Now let's deal with these products. We know that we expand multiplication using addition. So since I have 4 variables, I'm hoping to have 4 logs when all is said and done. Log base b of a plus log base b of y to the 5th minus log base b, I'm going to put that in parentheses because that was all in the numerator, log base b of m cubed minus log base b of n to the 4th. And then one more step, we've got those exponents to deal with, so we're going to go ahead and move those. And I'm going to keep these parentheses because it basically means that these were grouped in the numerator together, these were grouped in the denominator together, and I like them that way. Plus 5 log base b of y minus 3 log base b of m minus 4 log base b of n. And there it is in expanded form. Okay, so now let's look in the opposite direction and go ahead and condense. So last time what we started with was division, and then we went to multiplication, and then we dealt with exponents. So we're going to work in the opposite direction now, and we're going to do exponents first, and then maybe we'll deal with the subtraction, and then the addition. Okay, so again, these two are interchangeable. We do want to do this one first. Okay, so let's go ahead and deal with those exponents. Now, with exponents, when we're in expanded form, we find them out front. Okay, so we're going to want to take them and move them back to where they started before expansion. Okay, so we know that those come back up. So my first step, log base b of x to the 5th minus log base b of y plus log base b of z to the 1/4 power. Okay, so that takes care of my exponents. So now let's go down and deal with my subtraction. We know when we're condensing, subtraction goes with my division. So log base b of my first x to the 5th divided by my second y plus log base b of z to the 1/4. All right, subtraction is taken care of. Let's talk about addition. That addition we know is going to change to multiplication. Log base b of x to the 5th. And multiplication, since I would be multiplying x to the 5th y and z to the 1/4, that's going to go in the numerator. Okay. So I could stop here, but there's one thing I want to remind you of is when we talked about these rational exponents, we know that those are can also be written as radicals. So just to keep our minds fresh, we're going to go ahead and change that back to the 4th root of z over y. So now what we've done is we've condensed from 3 logarithms back to 1. All right, we're going to try one more of these and we'll be done for the day. Okay, so here's our last one. Natural log of 3x plus 1 minus the natural log of 3x squared minus 5x minus 2. So if we notice, we have 2 logarithms, so we want to go from 2 to 1. And what we're dealing with here is subtraction. So that means subtraction needs to change to division. First term goes into my numerator. Second term goes into my denominator. Okay, so what I'm thinking is I want to take this and see if I can simplify that out. The first thing that pops into my head is that this probably factors. So that's what I'm going to try and do. ln of 3x plus 1 over. We know we're going to have 3x and x. And we know it's going to be 1 and 2 because my only factors are 1 and 2. Now, a little hint to you is notice that this is 3x plus 1. The goal usually is to get something to simplify to be 1. So I'm going to try and see if this could work. So I'm going to put a 3x plus 1. We know the signs are going to be different because this is a minus, so this would be minus 2. Now, the way I can check to make sure that I'm correct is I could FOIL that back out and see if it works. 3x times x is 3x squared. 3x times negative 2 is negative 6x. 1 times x is positive x. And 1 times negative 2 is negative 2. So that gives me back a 3x squared minus 5x minus 2. And that's exactly what I wanted. So that does. Okay. So what winds up happening is these simplify to be 1. And what we have left is 1 over x minus 2. All right, guys, I went 50 seconds over. I apologize. The next video will be very short, so that should make up for it. All right, we'll see you tomorrow. Please come prepared with questions. Bye, guys.